Hello everyone, I am Dr. VNSR Venkateswara, working as Associate Professor in Freshman Engineering Department from Institute of Aeronautical Engineering, Hyderabad, Telangana. Today I would like to give the topic on the desalination. So first of all, what is the meaning of the desalination? Desalination is nothing but the process of removal of the salt, generally nothing but a common salt, sodium chloride from the sample of the water is nothing but a desalination. So generally the seawater containing the most amount of the salt percentage present in the water, nearly 3.5% of the water. So it is need to remove the salt content from the sample of the water for the purpose of to use the domestic and industrial purposes. So now let us see what is the process involved in the desalination. So first of all, desalination used especially for the water. Water is a good solvent. It contains so many amounts of the dissolved salts. Depending upon the amount of the dissolved solids, water may be classified as three types. That is mainly fresh water, brackish water, and seawater. That means depending upon the salts present in the sample of water, these can be classified into three types. Fresh water containing the less than 1000 ppm of the dissolved salts percentage, whereas brackish water containing the 1000 ppm to 35,000 ppm salts percentage, and finally the seawater containing the more than 35,000 of the ppm of the dissolved percentage. So that means what is the meaning of the ppm? ppm means parts per million. That should be equal to the 10 power 6 parts. ppm means parts per million, and it is equal to the 10 power 6. That means reciprocal of the 10 power 6 parts of the dissolved salts present in the water sample. First of all, we see fresh water. There is no problem because it containing the less than 1000 ppm of the dissolved percentage. Fresh water containing the less than the 1000 ppm of the dissolved salts percentage, there is no problem with the fresh water. But the main problem is the brackish water and the seawater. Brackish water nothing but the salt containing the salty taste or particular taste. So it containing the 1000 ppm to 35,000 ppm percentage of the dissolved salts, whereas finally the seawater containing the more than 35,000 ppm salts. So without purification of these two samples, nothing but brackish water and seawater, they cannot be used for the domestic and industrial purposes. So finally understand that it is need to remove the salts present in the sample of the water like brackish water and seawater by using the various types of the chemical treatment methods. So water containing the higher concentration of the salts is nothing but a brackish water, and due to the presence of the large quantity of the salts, it is salty in taste and it is unfit for the domestic and industrial purposes. This water can be put to the good use by removing the salts contents from it, and the process used for the removal of the salts from the water is nothing but a desalination process. And so many techniques by applying to remove the salts of the water, nothing but desalination. So for the purpose of desalination, we use mainly two techniques, that is reverse osmosis and electrodialysis process. These two are the physical treatment methods with the supplying of the chemicals. So mainly now we discuss the first one, reverse osmosis. So before seeing the reverse osmosis, we must learn about the osmosis process. So what is osmosis? Osmosis is nothing but one of the colligative property, and it tells about how the solvent flows from the one concentration to another concentration when both are separated by a semi-permeable membrane. And osmosis is a natural process. So osmosis is defined as the process of spontaneous of the solvent flow from semi-permeable membrane from a dilute solution to concentrated solution. That means dilute solution means lower concentration and concentrated solution means higher concentration. That means when two solutions of different concentrations are separated by a semi-permeable membrane, then the solvent flows from the lower concentration to higher concentration. That is nothing but a osmosis process. And the diffusion of the solvent particles takes place on account of hydrostatic pressure called as a osmotic pressure. In the osmosis process, we need a pressure that is osmotic pressure that should be applied from the lower concentration side in osmosis process, and which can act as a driving force for the solvent molecules to reach a equilibrium. So that is takes place at the semi-permeable membrane. So what is reverse osmosis? Reverse osmosis, from the title you understand that the osmosis is the natural process, whereas reverse osmosis is the, if you apply the external pressure, from higher concentration of the solution, then the solvent molecules move from the higher concentration of the solution to lower concentrations of the solutions, again when both are separated by a semi-permeable membrane. So reverse osmosis is the best process for removal of the any content from the sample of the water. Now let us see what is the definition for the reverse osmosis. If an external pressure equal to the osmotic pressure is applied on the concentration solution, the process of osmosis will stop, and if the external pressure exceeds the osmotic pressure, that means generally in osmosis we apply the osmotic pressure, but we apply the excess pressure than the osmotic pressure, then the solvent will be squeezed from the concentration solution side. This process is nothing but a reverse osmosis. Now let us see what is the diagrammatic representation of the osmosis and reverse osmosis. So in diagrammatic representation, what we learn from the first diagram, it is nothing but a osmosis process. See, direction of the water flow from lower contaminant or lower concentration of the solution to higher concentration of the solution. This is a natural process. In this case, we need not apply the excess pressure from higher concentration side. Why? Because generally the solvent moves from the lower concentration to higher concentration. It is the nature of the water particles or solvent particles when both are separated by a semi-permeable membrane. The semi-permeable membrane generally made with the cellulose acetate material. So in this case, we observe the solvent molecules moves from the lower concentration to higher concentration side. In this case, the external pressure is less than the osmotic pressure. Why? Because it is a natural process and the solvent molecules moves from the lower contamination concentration to higher concentration of the water particles. But we require the reverse osmosis. Reverse osmosis means the process involved in reverse osmosis, it is reverse to the natural process, nothing but a osmosis process. It is one of the colligative property and physical property also. So in case of the reverse osmosis, what happens? The solvent molecules moves from the higher concentration of the water to lower concentration, but this is generally naturally applied process. It is the reverse to the osmosis process. So we apply the external pressure which is greater than the osmotic pressure. We apply the external pressure which is greater than the osmotic pressure. Then only the solvent moves from the higher concentration of the water to lower concentration of the side, or higher contamination of the water particles to lower contamination of the water particles, when both are separated by a semi-permeable membrane. And the direction of the water flow which is also reverse to the osmosis process. That means in case of the direction of the water flow osmosis, what happens from lower concentration to higher concentration when both are separated by a semi-permeable membrane. But what happens in reverse osmosis? The direction of the flow takes place from higher concentration to lower concentration when both are separated by a semi-permeable membrane. So this is the main difference between the osmosis and reverse osmosis. So in reverse osmosis, pure water is separated from its contaminants rather than the removing the contaminants of the water. That means what happens? The contaminants are always present in the higher concentration. Higher concentration of the water means it containing the so many impurities. Then only we apply the pressure from the higher contamination water to lower contamination water. Those impurities are removed by reverse osmosis. This process is also called as superfiltration and hyperfiltration. Superfiltration and hyperfiltration. The semi-permeable membranes are usually made up of the cellulose acetate, polymethyl methacrylate, and polyamide polymers. All of these comes under category of the one of the monomers, and monomers undergo the polymerization to give the polymers. So those polymers are the example for nothing but a cellulose acetate, polymethyl methacrylate, and polyamide polymers. These three materials are very important for the manufacturing of the semi-permeable membrane. Out of three materials, you can choose any one of the material for the preparation of the semi-permeable membrane is sufficient. First one is the cellulose acetate, second one is the polymethyl methacrylate, and third one is the polyamide polymers. Out of three, you can choose the any one material manufacturing of the semi-permeable membranes. So, and what are the advantages and disadvantages of the reverse osmosis? First of all, we see what are the advantages of the reverse osmosis process. Generally, reverse osmosis not only applicable to the ionic and non-ionic, it can be applicable to any type of the materials from the sample of the water. Let us see, the process mainly removes the lead, calcium, magnesium, sodium, potassium, aluminum. All of these containing nothing but cations, whereas chloride, nitrate, fluoride, sulfate, boron, and most microorganisms and organic chemicals from the sample of the water. That means from this point you can understand the lead. Lead means Pv plus 2, and calcium means Ca plus 2, magnesium means Mg plus 2, sodium means Na plus, and potassium means K plus, and aluminum means Al plus 3. All of these nothing but cations. So these cations belongs to periodic table. Most probably first group and second group elements. That means alkali and alkaline earth metals. So these type of the metal ions can be removed from the reverse osmosis process. Now coming to the turn about anions. Anions means chloride Cl minus, and nitrate NO3 2 minus, and fluoride minus, and sulfate SO4 2 minus, and boron. So all of these nothing but anion category. So out of these anions, most probably observe the group nothing but seventh group elements. These seventh group elements are called as halogens. That means this type of the reverse osmosis is applicable to both cations and anions particles. And next one is the microorganisms. Microorganisms means nothing but the bacteria which is present in the sample of water. So these microorganisms will also nothing but chargeless particles. That means this reverse osmosis is not only applicable to the charged particles, it can be applicable to both ionic and non-ionic, and also organic chemicals from the water. That means there are so many effluents coming from the various types of the industries. So those chemicals is also need to remove from the sample of the water, even though that type of the chemicals can be removed by the reverse osmosis. So these are so many advantages by using the reverse osmosis. Now let us see what are the disadvantages of the reverse osmosis. So in reverse osmosis, it requires the large volume of the water and produces the high volume of the wastewater. So it is difficult to manage the waste water. That means of the completion of the reverse osmosis, it releases the so much of the water, and the disposal of the those wastewater is very main problem caused by the reverse osmosis. So this is the first process to remove the salt from the sample of the water, nothing but desalination process. Next we see the electrodialysis. So electrodialysis is nothing but from the title you can understand the charged particles undergoes the migration towards the respective electrodes when applied EMF, under applied EMF. That means electromotive force. Now let us see what is the definition for the electrodialysis. So electrodialysis is a membrane separation process that utilizes an electrical potential difference as a driving force for moving salt ions in solutions. The membrane is selective in that it will only permit the passage of either anions or cations, but not both. That means is it possible to move the either cations or anions, but at the same time both the ions should not be passed through the particular membranes. The separation is due to the charge rather than the size differences. That means there are mainly two charges, both positive charge and anion charge. The anion charge means negative charge. That means the size will depends upon these positive and negative ions. This process can be used to separate differently charged molecules of similar sizes. So now let us see what is the electrical potential difference. Electrical potential difference means with respect to positive and negative. Under the applied EMF, the salt present in the sample of water dissociates into individual cations and anions. Individual cations and anions. So after the dissociation of the salt into cations and anions, they can be marked as both positive and negative. So this is nothing but a electrical potential difference. So whenever the ions get the either positive charge and negative charge, they are not stable. They will be migrate towards their respective electrodes. And after that, what happens? The separation mainly due to the difference of the charge between these ions. So whenever the positive charge increases, positive charge increases, what happens? The size will be decreases. Ultimately, what happens? Negative charge, when negative charge increases, when negative charge increases, size will be increases. That means positive charge will be directly proportional to size decrease, and negative charge is directly proportional to size increase. That means from the potential difference between the ions, that means that may be either positive charge and negative charge, depends upon the size particles, they can migrate towards their respective membranes. So this is the main phenomena occurred in electrodialysis under applied EMF. So and let us see what is the principle involved in the electrodialysis. The process is mainly based on the principle that most salts that dissolved in the water are ionic, being either positively charged cations such as sodium, calcium, magnesium, or negatively charged particles anions such as chlorides and carbonates. These ions are attracted to the electrodes with an opposite electric charge, that is anion to cathode or positively charged electrode, and cathode to anode negatively charged electrode. That means generally this water containing the salts of the sodium, calcium, magnesium. So sodium belongs to group 1 and calcium, magnesium belongs to group 2. That means these group 1, group 2 elements are called as alkali and alkali earth metals. And negatively charged ions are nothing but a chlorides and carbonates. So these chlorides belongs to a 7th group are called as halogens. That means this process applicable to either charged particles only, that may be either positive charge and negative charge, and the ions attracted towards the electrodes with an opposite charged electrode. That means if we can take as anion electrode, anion to cathode or positive charged electrode, that means and cation to anode means negatively charged electrode. Depends upon the charge present on the electrode, these ions attracted towards the respective electrodes under applied EMF. So this is the main principle involved in the electrodialysis process. Let us see what is the diagrammatic representation of the electrodialysis. So anode negative pole present on the left side and cathode positive pole present on the right side. Under the applied EMF, what happens? Initially taken as a seawater is a feed water. Seawater is a feed water. So the seawater containing the salts, nothing but, for example, if you can take as sodium chloride. Under the applied EMF, what happens? The sodium chloride will be dissociates into sodium plus ions and chloride minus ions. That means the salt getting a electrical difference. That means that some of the ions convert into cations and some of the ions convert into anions. Cation is sodium and anion is the chloride. So these ions moves respective electrodes because of the potential charge difference. So depends upon the charge difference, the size of the ions will be finalized. So depends upon the size of the ion, they will be migrate towards the respective semi-permeable membranes or ion selective membranes. So these ion selective membranes mainly classified into two types: cation selective membrane and anion selective membrane. So cation selective membranes collected as a respective ions and anion selective membranes collected as a respective ions and release the oppositely charged species. So finally those oppositely charged species are converted into a concentrated or salt stream. Bottom of the diagram. concentrated or salt stream. So in the blue color, what happens? Fresh water channel. Fresh water channel. That means these sample of the water which can be removed the salts present in the water. So that is by the electrodialysis process. In this case, anions are represented by with red mark and cations are represented by blue mark. So this is very very important. This is nothing but a electrodialysis diagrammatic representation. So, and what is the procedure involved in the electrodialysis? As the cation selective membrane and the anion selective membranes are arranged in the alternative position, the space bounded by the two different membranes is called a cell. That means the cell containing the both cation and anion, two electrodes. That is nothing but a cell. And a unit cell or cell pair is made up of the two cells. The ion depleted cell for the passage of the fresh water. The freshwater channel or desalted water channel and the ion concentrated for the passage of the brain solution. These cells alternate between the freshwater channel and the brain channel. That means each cell is connected by its own feed or product stream of the brain stream. The unit cells and the electrodes are arranged horizontally or vertically. That means horizontally means it is the position of the plane line. Vertically means these lines. So because of these arrangements, the entire unit is called a stack. Entire unit is called a stack solution. The entire stack is commercially available from the manufacturers, such as so many materials. So salt solution from nothing but a seawater enters into a parallel path through all the cells while an electric potential is maintained across the electrodes. So that means electric potential is very very important and applied EMF. So the positively charged cations in the solution migrate towards the cathode and the negatively charged anions migrate towards the anode. Already we discussed cathode and anode. So these selectives their respective electrodes. So cations easily pass to the negatively charged cation exchange membrane, but they retained by the positively charged anion exchange membrane. So based on this line, these ions can be removed. Cations are easily passed to the negatively charged cation exchange membrane, but they retained by the positively charged anion exchange membrane. Similarly, anions pass through the positively charged anion exchange membrane but are retained by the negatively charged cation exchange membrane. So based on this line, we can understand how can you remove the cations and anions. So for example, in the freshwater channel, the anions are attracted and diverted towards the cathode, while at the same time, the cations are attracted and diverted towards the anode in an opposite direction to the movement of ions. The anions pass through the anion selective membrane into the brain solution, and the anions cannot pass through the next membrane because it is the cation selective membrane. That means anion selective membrane collects only anions, whereas cation selective membrane collects only cations. That means depends upon the charge potential based on the ion selective membrane. The anions are therefore trapped in the brain solution. Brain solution nothing but a sodium chloride solution. This is called brain solution. So likewise, the cations also pass through the cation selective membrane into the brain channel, and cations also trapped in the brain channel as the next membrane as the anion selective. That means the cations movement will be continue up to the anion selective membrane only. That means the freshwater containing the depleted of both cations and anions through the migration across the membranes. At the same time, the brain channel next to the freshwater channel becomes the enriched in the cations and anions. That means all the cations and anions in the seawater can be concentrated in a brain solution. And from the next digit, we see the diagram. Freshwater comes down. So now see what are the advantages of this electrodialysis process. The unit is the very very compact, and the process is economical as far as the capital cost and the operation expenses are the concerned. That means it is economically best method when compared to the reverse osmosis process. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.